Number 9 and 2.6 in the book here, if you read your directions carefully, guys, they're telling you straight out here that you need to use the squeeze theorem on a problem like this. None of the other methods that we had talked about would work on this problem anyhow. So let's see if we remember our 3 steps to the squeeze theorem. The first step is to take the trigonometric portion of the function you're taking the limit of, and make that bounded. So the trig portion is always going to be sine or cosine in a squeeze theorem problem, and it needs to include the angle as well, which in this case is pi over x minus 1. And sine of any angle is always going to be bounded in between -1 on the lower end and +1 on the upper end. So it doesn't really matter what this angle is here, guys. Sine or cosine of any angle always needs to be, how do I want to read this, less than or equal to +1. And if I read it backwards, that sine always needs to be greater than or equal to -1. So that's step 1, make the trig portion bounded. Step number 2, do whatever you need to do to make this trigonometric portion, which we got from right here, look like the entire function that I have in those blue brackets. So all that's missing is that we need to multiply by the binomial quantity x minus 1. So this -1 gets multiplied by an x minus 1 right there, and I'm going to go ahead and make that could either be a -x plus 1, or you could have made that a 1 minus x. That would have worked out fine. Is less than or equal to, okay, we multiply the middle portion by x minus 1 as well, and we simply get this. Gotcha, which is less than or equal to, let's multiply this right portion times x minus 1 as well, and we'll just get x minus 1. Now, sometimes step 2 can take 2 or 3 or conceivably even more steps than that. But in this case right here, in one step, we now got the middle portion of this compound inequality to look exactly like the original function. So step 2 is done. And step 3 now is to wrap everything up, but I should at least think before I do this. We're doing a limit as x approaches 1, and what's the limit of? Remember, this is what we usually call our lower or our f of x function. That limit, as x approaches 1, that's the opposite of 1 plus 1, which is 0. And then this function over here on the right is our upper limiting function. We usually call that h of x. And when x approaches 1, this becomes 1 minus 1. That is going to be 0 as well. So because f of x and h of x have the same limit as x approaches 1, then this middle function must have the same limit as well. So here's what we're going to write, guys. Since the limit as x approaches 1 of our lower limiting function, -x plus 1, since that limit is equal to the limit as x approaches 1 of our upper function here, x minus 1, and since both of those limits are 0, then we may conclude that the limit as x approaches 1 of our function, the one we care about, x minus 1 times the sine of pi over x minus 1, that limit has to equal the same value as the other two limits, which is going to be 0 as well. So that's how we do a squeeze theorem problem here in 2.6, number 9.